Okay, so we want to use linear approximations to estimate natural log of 2.5. And so our first task is to say, okay, well, what's my function? So my function is going to be, so you look at what you're estimating, and so you just make that your function, and instead of your number, you would just put x. So natural log of x would be my estimate. Then you have to look for a point that's close to the one you're looking for. The closer the better, but you want it to be one that you can actually find. So if you think of the numbers that you can actually find the natural log of, near 2.5, you go, oh, hey, e is about 2.7, so let's use that number. So we're going to find the tangent line of natural log of x at x equals to e, and so this is what we're going to use to approximate natural log of 2.5. Okay, so the first task, as usual, is to find the derivative. So the derivative of natural log of x is 1 over x, and so the slope, m, is the derivative at e, which is the point that we're finding the tangent line at. So this is just 1 over e. Okay, so then we find the tangent line. So I have y equals to mx plus b. I plug in my my slope, which is 1 over e. I plug in the x value, which is e. That's the value that I'm using. And then remember the y value, all you have to do is plug in the x value into your function. So you get natural log of e, which is simply 1. Okay, well, great. This is actually much simpler than it looked in the beginning, because notice here you have 1 over e times e. That's simply 1 for this whole thing right here. And the left side is 1. So what you have is 1 is equal to 1 plus b. Well, what does that give you for your y-intercept? Your y-intercept is simply 0. Whoa. So your tangent line, super simple. Y is equal to 1 over e times x. And that's it. That's your tangent line. Or also known as the linearization of natural log of x at x equals to e. Okay, so then the next part is we want to approximate natural log of 2.5. And so we say that natural log of 2.5 is approximately equal to plugging in 2.5 into this function. So I have 1 over e times 2.5. And this is equal to, you would need a calculator, of course, because you need to find 1 over e. That's not easy to find. But that's okay, you get the idea. This would be 0.9196986, and that's good enough. Okay, so this is the approximation. Now the if I want to find the error, I would need to find the actual. So the actual is natural log of 2.5. If you plug this into your calculator, you would get 0.9162907. How many decimals? That's 7 decimals. Okay, same amount of decimal places. Okay, so then the error is equal to the absolute value of the actual, 0.9162907, minus the approximated, which is 0.9196986. That's equal to 0.0034079. Okay. So that's the error, and then the percent error, remember, is just the error 0.0034079 divided by the actual, which is 0.9162907, and then multiplied by 100%. And so if you do all that, you would get 0.3719%. So again, pretty close.